Reflection. We're going to use the ray box equipment. Here we see a single light ray and multiple rays. And on the other side we can insert filters and use the mirrors to add colors. First reflection off a flat mirror. We've just seen this situation. Let's put a blue line where the mirror is, and we see how the incoming ray, we call the incident ray, and the reflected ray. If we draw a normal line that's at right angles to the surface at the point where it strikes the mirror, then we can define the incident angle and the reflected angle, and the law of reflection says that those two are always equal. Without the photo, consider a person looking at a full-length mirror. The ray that reflects off the top of the head that he can see travels like that, and the one from his foot travels like that. Because we've learned to interpret light travels in straight lines, his brain perceives the image to be an equal distance behind the mirror. There's no light going to this image. It appears to be coming from the image, and that is what we call a virtual image. It's not one that can be cast on a screen. Incidentally, you only need a mirror half the height to be able to see your whole reflection. Ever ask yourself why so many people don't like photos of themselves? Well, the one's a mirror image and the other's not. I've pulled an asymmetrical face and combed my hair to the side so you can see the difference. I'm also holding up a sign that says which is real. So it's pretty obvious now that the one on the right is a mirror image. We call this lateral inversion. And that's why we have all these ecnalabmas driving around, because if you're driving in front of them and you look in your rear view mirror, that's how you will read it. Why don't you try this? Write your name in such a way that when you hold it up against a mirror, it reflects correctly. That will be depending on how you hold the mirror. What do you think this spells? Well, you can see the person holding the mirror, and Luke wrote his name correctly as a mirror image. If you consider turning it through 180 degrees, then if you hold the mirror differently, you can also read it. Now we use multiple rays to show how a curved mirror, a concave mirror in this case, converges the light rays. By turning it around, we see how the convex mirror diverges the rays. Here we have a photograph taken, myself with my parents at a science center. And this is the photograph that was taken with that camera. You can see the image is upside down. But as I walked closer, it gets to a point where I'm upright. A more dramatic one, my brother behind me is taking the photo and he appears to be upside down, but I'm closer than the focal length and you get this huge distorted image. A compact mirror that women sometimes use for putting makeup on also enlarges the image. A convex mirror is sometimes used at traffic intersections, and it allows the user to see a wider angle. And that's it so far.